Welcome to the deep dive. It's a strange situation we're seeing in software development right now.
Hmm.
AI is writing more and more code, which you think, logically, means fewer bugs,
That's
right?
right. Makes sense. Yeah.
But, well, the reality seems to be the opposite. Software bugs are actually kind of on the rise.
It's pretty counterintuitive.
So today we're going deep into what we're calling AI-powered entomology. Basically, the study of bugs using AI,
Hmm.
how AI is being used to find errors in code, but also the complexities and some really surprising human factors that come into play.
That's exactly it. And our mission here is to unpack some, honestly, quite eye-opening insights from Thomas Reimers. He's the co-founder at Graphite.
Right, they build Diamond, the AI code reviewer.
That's the one. And their perspective comes from looking at literally millions of AI code reviews. So we're trying to figure out not just if AI can find bugs.
Which it seems it can, sometimes.
Right? Sometimes. But also what kind of bugs it's good at finding. And maybe the most critical piece, what kind of feedback do we as humans actually want from an AI?
It really gets down to that core question, doesn't it? If AI writes the code, can it also clean up its own mess, essentially, find the bugs?
Can it be the solution? Yeah.
So, okay, when Graphite first started looking into this, maybe about a year ago, how did they even begin? What was the first approach to AI bug detection?
Well, like a lot of folks, they started, pretty simply, they just asked large language models, LLMs, like Claude, to look at a code change.
A pull request or PR?
Exactly, a PR. And just, find the problems, find the issues.
And what happened? Were the results any good?
Initially, yeah, they were genuinely impressive, actually.
Impressive. Like how? Give us an example. What was it catching?
Sure. So they had real cases from their own system.
Hmm.
One time, the AI spotted an uninstantiated database ORM class.
Okay, technical term, but basically something important wasn't set up right.
Right. It would have just crashed their server. Gone unnoticed. Boom. Server down.
Wow, okay. That's a serious catch.
Definitely. And another one, this one got shared around a bit. The AI found math errors in calculating border radii for the UI.
The visual stuff.
Yeah, and the error led to dividing by a negative number, which, again, crash. This time the front end, what the user sees.
So early days, it seemed like, okay, AI can find real, impactful bugs.
Yeah, was the initial feeling, yes.
Yeah.
A resounding, this works.
But there's always a but, isn't there? Especially with new tech. Anyone who's used these tools has probably felt this next bit. What started to go wrong? Where did the frustration creep in?
Oh, yeah. Developers started getting swamped with comments that were, well, annoying, pedantic, or sometimes just completely wrong.
Like what?
Imagine getting a comment saying, you should update this code to do what Clarity does. And you think, what on earth is Clarity? Some internal thing nobody defined.
Right, totally unhelpful.
Or CSS doesn't work this way when, you look at it and test it.
Yeah.
And it absolutely does work that way.
Huh. Yeah, I can see that being irritating.
And maybe my favorite, the kind of thing that really makes you sigh, is you should revert this code back to what it used to do.
Why?
Because it used to do it.
Yeah.
No other reason given.
Oh, come on. That's not helpful feedback.
Not at all. And comments like these, they really started to chip away at the trust developers had in the AI suggestions. Confidence just plummeted.
Okay, so this is interesting. They're seeing genuinely good catches like server crashing bugs, but also this flood of just noise, annoying, wrong stuff.
Mm-hmm.
How did they get past that? How did they figure out what was really going on underneath the frustration?
That led them to a really crucial insight. A breakthrough, you could say. They realized it wasn't just about what the LLMs were capable of catching.
It wasn't just a technical problem.
Exactly. It was about what humans actually wanted to receive from an LLM. That shift in focus from capability to human preference, that changed everything for them.
And there was this really fascinating moment they described, wasn't there, involving their design team?
Yes. This was great. They sat down, developers and designers, looking at a mix of old comments, some from AI, some from humans.
Okay.
And the developers, they were surprisingly consistent. They'd look at a comment and say, yeah, I'd be okay if an AI said that. Or, nope, absolutely not okay from an AI.
We had a clear line.
Pretty much.
Yeah.
But the designers were just baffled. They'd see two comments that looked, on the surface, quite similar in terms of suggesting a change.
Okay.
And they'd ask the developers, wait, why is this one okay, but that one, which seems almost the same, isn't? You really drove home how subjective this feedback thing is.
It's not just about technical correctness, then.
Not at all. It's about, well, they started calling it the human barometer.
A barometer, like for weather.
Sort of, yeah.
Yeah.
An internal gauge that developers use.
Yeah.
It helps them decide based on context when a suggestion like, say, you should extract this logic or add a comment here is actually helpful.
Versus when it just feels like nitpicking or, just annoying noise, especially coming from a bot.
Precisely. And that nuance, that judgment call, the AI, at least back then, really struggled with that. It didn't have the barometer.
So to really understand this, to map out this subjectivity, Graphite did a pretty big study, right? How did they approach trying to quantify this human element?
It did. It was quite comprehensive. They gathered 10,000 comments, pulled from their own code, plus a bunch of open source projects.
Okay, a big data set.
A decent size, yeah. Then they fed these comments to different LLMs, not just once, but multiple times, asking the AIs to categorize them, just to make sure the categorization was reliable.
What were they categorizing them based on?
This painstaking work let them define two really critical axes for thinking about AI feedback.
All right, what are the axes?
Okay, axis number one is about the AI. LLMs can catch this type of issue versus LLMs can't catch this type of issue. Pretty straightforward capability axis.
Makes sense. Capability.
Axis number two is the human side, the really interesting part for collaboration. Humans want to receive this feedback versus humans don't want to receive this feedback.
Ah, okay. Capability versus desirability, almost.
You could put it that way, yeah. And when you plot these two axes, you get 4 quadrants. Each quadrant represents a different category of code review comment.
Let's break those down. Let's start with the ideal scenario. Quadrant 1, LLM can catch it, and humans want it. The sweet spot, what lives there?
This is definitely where AI is a huge win, and developers are generally happy to get these comments. Think logical inconsistencies, genuine bugs where the code just doesn't do what it's supposed to.
Okay, real bugs.
Real bugs. Also, accidentally committed code, like leftover debug statements or secret keys. You'd be surprised how often that happens.
I believe it.
Performance concerns, security vulnerabilities, those are big ones. And clear mismatches between the code and its documentation. If the comments say one thing and the code does another, that's a problem.
Right, these are all things that directly affect how the software works or how safe it is. No wonder people want to know.
Exactly. They're functional, critical,
Yeah.
universally welcomed.
Okay, now, quadrant 2. This is where LLMs can't catch something, but humans do want that information. This sounds difficult for AI.
It is very difficult.
Yeah.
Because this quadrant is mostly filled with what they termed tribal knowledge.
Tribal knowledge. What does that mean in a code context?
Imagine someone reviewing code and leaving a comment like, hey, just a heads up, we used to implement this pattern, but we stopped about 2 years ago because it caused that major outage, remember?
Ah, the unwritten history. The team lore.
Precisely. That kind of crucial context often only lives inside the heads of the more senior developers. It's not in the code itself. It's not usually written down in documentation.
So how can an AI possibly know that?
It really can. Not easily, anyway. It's almost like asking the AI to mind read the team's history. That's a huge barrier right now.
Yeah, I can see that. Okay, on to quadrant 3. This is where the LLM can catch something, but humans don't want the feedback. This is the annoying zone, right?
This is absolutely the annoying zone. This is where a lot of that initial frustration came from.
So what kind of comments fall here? Give us examples.
These are mostly suggestions related to code cleanliness, best practices, that sort of thing, like add a comment describing what this class does, or you should add unit tests for this code.
Right, or extract this block of code into its own function. Things that are generally good advice.
Generally good advice, yes.
But the AI suggesting it feels wrong somehow. Why is that? If it's technically good practice, why is it unwelcome from an AI?
This is where it gets really interesting. It comes back to that barometer, that human judgment.
Okay.
A human developer knows, okay, this specific piece of logic is unusually complex, or it's tripped people up before. Here, yes, extracting it or adding a detailed comment is really valuable.
We have the context.
They have the context. Or they might know, actually, this bit is straightforward. It follows a standard pattern. Adding tests right now is overkill. Or extracting this would just make the code harder to follow in this specific case.
So the human applies nuance.
Exactly. The AI, lacking that nuance, can basically always suggest adding comments or extracting functions. It sees the pattern, makes the suggestion. Broadly applying technically correct advice feels pedantic, like being lectured by a machine that doesn't understand the bigger picture.
It's the difference between helpful guidance and, like, robotic nagging.
That's a good way to put it. It's about the welcomeness, the timing, the appropriateness of the suggestion in context, not just whether it's technically sound advice in a vacuum.
Okay, so they've got these categories, they understand the types of comments, but then the next big step is measurement, right? How do you make sure the AI is actually staying in that good quadrant one, can catch humans want, especially as the AI models themselves change or you give them more data?
That's a really critical question for building a useful tool. How do you ensure continuous rightness, basically? They tackled it from two angles, mapping back to those two axes.
All right, angle one, measuring capability.
Measuring LLM capability, the can catch, can't catch part.
Yeah.
They did something pretty direct. They built upvote and downvote buttons right into their product, right on the AI's comments.
So users can give immediate feedback.
Yep. And for them, a sudden spike in downvotes is a clear signal. It tells them, hold on, the LLM might be starting to hallucinate.
Making stuff up.
Yeah, generating inaccurate or nonsensical comments. Or maybe we're pushing the AI too hard, asking it to comment on things beyond its current understanding. We need to pull back a bit.
And how's that working? What are the downvote rates like?
Encouragingly, they said they see less than a 4% downvote rate nowadays, which suggests they've gotten pretty good at keeping the AI operating within its actual capabilities.
Okay, less than 4% sounds pretty good. That handles the capability axis, but what about the other one? Measuring human preference, the want, don't want axis. That feels fuzzier, harder to measure.
It definitely is trickier. But they thought about the fundamental purpose of a code review comment. Why do we leave them?
To get the code improved, right, to get something changed.
Exactly. The ultimate goal, usually, is to trigger a change in the code itself. So their core question became, can we actually measure the percentage of AI comments that lead to the suggested code change?
Measuring actionability. Did the comment lead to action?
Precisely. So they started analyzing this, looking at open source projects, looking at private code bases they had access to. First, they needed a baseline.
What do humans achieve?
Right. What percentage of human comments lead to a code change within that same PR? And the answer was kind of surprising.
Oh, surprising. High, low.
Surprisingly low, actually. They found only about 50% of comments left by human reviewers result in a code change in that specific pull request.
Only half. Wow. Why so low? I would have guessed higher.
Yeah, it seems low at first glance, but there are good reasons. A lot of comments are what they call fixed forward.
Meaning
Meaning the author sees the comment, agrees, but says, okay, I'll address this in a follow-up PR, not this one.
okay, deferred fixes.
Right. Other comments are just heads-up suggestions. Maybe think about this next time, or we should refactor this area later. No immediate action needed.
Informational comments.
Yep. Some are purely stylistic preferences, like I'd name this variable slightly differently. And, in a healthy team environment, sometimes there's just disagreement. The author might push back respectfully, and no change is made.
So 50% actionability for humans isn't necessarily bad. It just reflects the reality of code review.
Exactly. So that became the benchmark. The goal for their AI, Diamond, wasn't perfection. It was just, can we get the AI's comment actionability rate to at least match that human baseline of 50%?
Okay, the moment of truth. Did they hit that target? Can the AI be as effective as a human in getting code change?
They did. As of March, they reported reaching a 52% actionability rate for Diamond's comments.
52%, so slightly better than the human average in their data.
Slightly better, yes. By carefully prompting the AI, focusing it on the right types of issues, those quadrant 1 issues they managed to make its comments lead to code changes just as often, or even slightly more often, than typical human comments within that PR context.
That is genuinely impressive. That feels like a real success metric.
It's a huge milestone, yeah. It shows it's possible.
So wrapping this all up then, what's the big picture here? The broad thesis seems pretty clear now. AI-powered bug detection, AI code review. It does work. It's not just hype.
It absolutely works. But, and this is the crucial, but it only works effectively if you're super careful about what you measure.
Right. It's not enough just to check if the AI can technically find something.
No, you have to measure its technical capability, yes, but just as critically, you have to measure the human side. The receiver's preferences, their willingness to accept the feedback, and ultimately the actual impact. Does it lead to better code?
It's about designing for that human-AI interaction, not just the AI's brain power. Understanding human receptiveness is key.
That's the core lesson, I think. Designing for genuine collaboration.
This has been really insightful. We've unpacked a lot. Those two axes, capability and human desire, the, surprising subjectivity around comments that seem similar but aren't received the same way,
Yeah, that barometer concept.
and these really innovative ways to measure if the AI is actually helping by tracking user reactions like votes and, even more importantly, tracking whether the code actually gets changed. These
Oh.
are big
They
takeaways.
really are. And they feel like they apply beyond just code review, too.
Definitely. Which kind of leads us to that final provocative thought for you, the listener, to maybe chew on.
Mm-hmm.
If this study shows that making human AI collaboration work well in a technical field like programming depends so heavily on understanding not just what the AI can technically do, but what humans will actually accept and act on.
Yeah, that receptiveness factor.
What does that imply for designing AI tools in, well, pretty much any other professional field? Think about medicine, law, finance, creative work.
Everywhere AI is starting to integrate.
Could it be that understanding and designing for human receptiveness is going to be just as important, maybe even more important sometimes, than purely maximizing the AI's raw analytical or generative power? How crucial is that human acceptance piece for the future of AI across the board?
Something to think about, definitely. How much does the human factor gate the AI's potential in practice?